What if we had no neurons? What if there was no sense of communication between our brain and our nervous system? The answer is simple. We couldn't do anything. You see, the brain is composed of about 1 billion neurons, each in charge of a certain function. It might sound crazy, but they actually communicate with each other. They send messages electrochemically. Action potential is a way that these neurons communicate with each other. This might sound like a crazy process, but it really isn't. However, in order to understand action potential, we need to understand the neuron. A neuron is composed of dendrites, axon, myelin, and axon terminals. These all play a part in the communication between each neuron. Now, if we take a closer look at the axon, you'll notice small gaps between each piece of myelin. These gaps are called the nodes of Ranvier. The ion channels that are located between the nodes of the Ranvier are here for a quicker movement of ions. Ion channels are closed when a neuron is in its resting stage. The voltage at this stage is negative 70 millivolts. You see, the neuron is only able to create an action potential because of a concentration difference between potassium and sodium ions. To help better illustrate this, let me take a banana and roll it in salt. We'll sprinkle it with salt really. Now, whenever you think of a neuron and action potential, just think of a salty banana. However, please note that the space outside of the cell is slightly more positive than the space inside of the cell. This happens because of leaky ion channels, as it let in a small amount of sodium ions and release a small amount of potassium ions. We'll get back to this later. When a neuron communicates with another neuron, it causes the ion channels to open. When this happens, sodium ions enter inside of the cell. This effect is known as depolarization, which then causes a chain reaction of the opening of many ion channels. Sodium fills the inside of the cell and increases the voltage to 40 millivolts. Once the voltage reaches 40 millivolts, the repolarization effect occurs, which then removes sodium ions from inside of the cell. This step, however, removes too many sodium ions and then causes the cell to move into hyperpolarization. Remember when we talked about the leaky ion channels? These are crucial to this stage as they stabilize the cell to its original resting voltage of negative 70 millivolts. Once this travels through the axon, it reaches the axon terminals, which then release neurotransmitters that are then transported to another neuron that start the process all over again. And that is how simple action potential is. Now, I will ask you again, what will happen if we had no neurons?
Up in paradise, I suppose. If you would tell me I'm the only one that you love, life could be a dream.